Hello! So today we are going to talk about the square. So let's start. This figure in front of you. Of course it's not a square, but we are going to ask some questions about it. So try to answer, to follow with me. Okay? So first of all, what do we call this figure? What is it? Is it a square, rectangle, parallelogram, rhombus, or none of them? So, of course, it's none of them. This figure, it is a quadrilateral in general. It is a quadrilateral. Why it is a quadrilateral? Because it has four sides. Okay, so it has one side, two, three, and four. That's why we say it quadrilateral. So it's, cuatro, the Spanish letters. So here where it comes from the Latin word. So quadrilateral because it has four sides. And what do we call the points A, B, C, and D? So the point A, what do we call it? So we say that A is a vertex, B is a vertex, so C and D are also vertices. Okay, and our next question is, what do we call this segment AB or BC or CD or any segment of them? So AB is a side of the quadrilateral, also BC and etc. And how do we name, finally, how do we name the angle? So if we want to name this angle here, how do we name it? Okay, so if we want to name this angle, we say that it is DAB. It is very important that the vertex is the letter in the middle. Okay, we can start this way, DAB, or we can start from this side, BAD. It is also correct, and we put the angle sign. Okay, so all these information are found here. So oh, I missed something. AC, what do we call AC and BD? So the when we connect the opposite sides, the opposite vertices to each other. So AC is a diagonal, and DB also is a diagonal. So this is a quadrilateral. It has four sides, and we name them. Okay, so notice that the side we use a segment. Okay, from A, and a segment here also. So these are the sides. So we can say it AB or BA. It's the same, of course. And the four angles also we also have said that DAB. We can say it is BAD, and it's the same angle. We have four angles, two diagonals, and the sum of the angles is 360 in any quadrilateral. Moving on, so finally we are going to talk about the square. What is the definition of a square? So a square is a quadrilateral with four equal sides and four equal angles. So the four sides are equal and the four angles are equal. We are going to talk more about that. This is the definition, but these are not all the properties about the square. So here are the properties of a square. Let's start. Number one, all the sides are equal. So we have said that AB, what are the sides of a square? AB, BC, CD, and DA. These are the sides. So all of them are equal. So if AB equals 4 centimeters, this is 4, this is 4, this is 4. If this is X, any value, X, okay, I'm sorry for that, X. Okay. So let's write it correctly. If this is X, for example, this will also be X. Do not say, oh, what is X? I don't know what is X. This is X, as simple as that. This is X, this is X. So whatever AB is, or any one of this, any side of these sides is, the other sides have the same value. If we know it, then great. For example, we said that if it is 4, then all of them are 4, great. If we do not know it, then a variable like X, Y, then all of them have the same value, which is this variable. So this is number one. Number two, all the four angles are equal to 90 degrees. So we have said that we have four angles. This is the first angle, angle A, in which we call it DAB. It is equal to 90 degrees. Angle B, angle C, angle D. You can see this is small square on the angle. This means that this angle is 90 degree angle. The opposite sides are parallel. So what are the opposite sides? Let me call them. So if this is S1 I mean by it side 1, side 2, side 3, and side 4. So let's say what are the opposite sides. So S1 and S3, they are opposite sides, so they are parallel. So we write that S1 is parallel to S3. Okay, or you can write it as AB, not S1. So we can say that AB is parallel to DC. And of course, when we talk about parallel, we do not say segment, it is the line. The line AB, it is parallel to the line DC, of course, because even if we elongate this line from the side of A and from the side of B, so if we mean that all of the line, okay, I'm sorry, that was below. So if we elongate that, these two lines, the line AB, all of it will be parallel to the line DC. So it is not just this space between A and B. It's not the segment AB. It is the line AB. All of the line AB will be parallel to all of the line DC. Okay. Opposite sides are parallel means S1 is parallel to S3, and also means that this is the first pair of opposite sides. The second pair is S4 and S2. So AD, the line AD, this line, and the line BC also. So also we can write, okay, I'm sorry for that. Also we can write S4 is parallel to S2. Also I can write it here like in parentheses. S4 is parallel to S2. So this is the third point. It means S1 parallel to S3 and S4 parallel to S2. These are the opposite sides. And finally, diagonals are equal, perpendicular, and bisect each other. So wait a minute. This point contains three it contains details. So equal, perpendicular, and bisect each other. Equal, it's easy. So the diagonals are equal. What are the diagonals? So first of all, the first diagonal is AC. It is drawn in red, and the second one is DB. So they are equal. Equal means they have the same measure. So if AC equals 2, then DB is equals to also 2 centimeter. If AC is X, then DB is X. If AC is X plus 2, for example, DB is X plus 2. So they are equal. Perpendicular means they have a 90-degree angle between them. So this angle is 90 degrees. So we can check if the diagonals are perpendicular by using a set square, and we put it between in the angle formed between the two diagonals, and you can see that it fits correctly. So this angle is a 90-degree angle. Okay, so the diagonals are perpendicular. So when I write this sign here, it is a coded property. We say if this is perpendicular, then this is also perpendicular. So it is the same, all of them are perpendicular. Okay, so but no need, of course, to draw all of these little squares because it will be very messy. So I only draw one. So equal, we understand that. Perpendicular, we understand that. Bisect each other, what does that mean? Bisect each other means it intersects at the two diagonals intersect at their midpoint. So we have said that the diagonals are AC and DB. So O, they are saying that if they bisect each other, that means that O is the midpoint of AC. Also, O should be the midpoint of BD. So if O is the midpoint of both AC and BD, then we say that the diagonals bisect each other. Okay, so let's make sure by bringing up a ruler and see if these two diagonals, if this point O is the midpoint of AC, first of all. So AC is about 8.5. So the midpoint of half 8.5, if you divide 8.5 by 2, it will be 4.25. So 4.4 and between 2 dashes and 3 dashes, these small dashes, Okay, so it is exactly that. It's between the second and the third dash. And also, if we want to make sure also if O is the midpoint of DB, and of course that will be true. Okay, so you can see that 4 point between 2 and 3, so it will be 4.25. Okay, so the diagonals also bisect each other. Okay, so eventually we have said that OAC is equals to DB, and O is the midpoint of AC and DB. Then we will have AO is equals to OC, because O is the midpoint. So let's take an example. If AC is 4, this small segment AO will be 2, and this segment OC will be 2. And we have said that if AC is equals to DB, yes, they said that the diagonals are equal. So if this is 4, then DB is also 4. Then also come in O is the midpoint of DB. Then if this is 4, the midpoint is 2 and 2. So I will put the same sign. So also DO is equal to OB. So you see those small segments AO, OD, OC, OB, they are equal. Okay, so here these are all the properties of the square. You should memorize them. So next we will talk about the symmetry, and I put this figure in order to refresh our memory. What is a symmetry? So you can see this red line is the axis of symmetry, in which the lines and everything on this side is the same and is in an equal distance on the other side. So if you can say, for example, this if we take any point here, and we see the distance from this point to the red line, and from the red line we will have another point which is its image on the second side. So for example, if we took this point and we measure from this point to the red line, it will be the same distance from the red line to its image. So this is the symmetry, and we will talk about it. So the symmetry, we have two kinds of symmetry. We have symmetry with respect to a point and symmetry with respect to a line. And you should know how to draw the symmetry with respect to a point and how to draw the symmetry with respect to a line. And we are going to talk more about each one of them. So let's start with the symmetry with respect to a point. Okay, so the question will be like this: draw E, the symmetry of B with respect to A. So it's a shortcut with respect to, okay, A, and H, the symmetry, oops, this is a wrong dictational mistake, the symmetry of A with respect to F. So we should draw two symmetries. Let's take the first one. Draw E, the symmetry of B with respect to A. So you search, when we have the word symmetry, you should search for this word with respect to, and look for the letter which they write it after this word. So with respect to A, this means that A will be in the middle. A will be the midpoint of these 2 points. A will be the midpoint of E, B. A will be in the middle between A, E, and B. Okay, so this is B. We should draw E, in which A is in between B and E, in which the point we will draw it. So we will first of all, how to draw that? First of all, we should connect B, E. Okay, so I will use a ruler and draw a straight line between connecting B and A. Okay, so that will be 5 centimeters. So I drew the line from B to A. Okay, and then I need the same distance because A is the midpoint. So from A I will complete, okay, till 10, and that will be 5 on this side and 5 on this side. So this point where I ended the line, this is the point E. Okay, so E is the symmetry of B with respect to A. So the first thing, whenever we see symmetry, we search for the word with respect to. After this word, it will be the midpoint. So A is the midpoint of EB. Let's try with the second one. H, so we should draw H, the symmetry of A with respect to F. So we search for this word with respect to. We look at the letter after that, which is F. So F is the midpoint. Okay, so we should draw H, the symmetry of A with respect to F. F is the midpoint. This is A, this is F, which will be in the middle, and we should draw H in this side here, somehow here. Okay, so what we are going to do is we bring the ruler, we draw a straight line connecting. Okay, let me just make this ruler smaller. Okay, so we will draw a line connecting A and F. It's not a perfect measure from A to F. Okay, no problem. So from A to F we have about 4.2. Okay, so we are going to draw also 4.2 centimeters to the other side of F. Okay, so you can move the ruler, okay, and draw 4.2. Of course, make sure it is a straight line. Okay, and we can draw till we reach 4.2, and this is the final result. So this point here, we will call it H. So H is the symmetry of A with respect to F. F is in the middle. So this is the symmetry with respect to a point. Very easy to draw, very easy to understand and remember. We just look after with respect to this letter here is in between, and we measure. Now let's see the symmetry with respect to a line. Okay, so let's see how the question will be. Draw EFG, the symmetry of ABC with respect to a line. So they are asking us to draw like a figure on the other side. It's not just a point, okay, or not a segment. So in this example, a point, we are moving a point, okay, with respect to a point. But here also we move it point by point, but it is a big figure. So let us define first of all where are the points. So the point A, the point B, the point C. Okay, so here are 3 points. I should make a symmetry of these 3 points with respect to the line D, and eventually I will obtain another rectangle here. So after I decided what are the points, okay, I will just mark them for you to see them. So it's the point A, it's the point B, it's the point C. We will work each point alone. Okay, so let's take the point C. So our first step is we should bring a set square and draw a perpendicular from each point to this line D. So we are going to draw a symmetry with respect to D. Also, as I have said in the last slide, so after with respect to this D, but it's a line here, it will be in the center. It will be the midpoint. Okay, so what we should do is we should bring our set square and draw a perpendicular from each point. So oops, my bad. Okay, so let's draw a perpendicular from C to this line. So this is our first point to the line. Okay, so we will complete it down to the line D, and let's draw also a perpendicular from B to the line D. So we should draw a perpendicular from each point of these 3 points. Maybe I have 4 points, I don't know. However, how many points I have, I draw a perpendicular from each point that I have in the figure. And so I draw a perpendicular from B, and also I will move it till I reach A, and I'll draw a perpendicular from A. So you can see that the base of the set square is on the line D, and I am drawing a perpendicular line from A to the line D. From A to the line D. Okay, so after I have drawn these lines, and I reach them till this line D. Okay, I have like it is not till the end. Okay, now I also want to complete this figure. We said that the D is in between, it is the midpoint. So we want to complete these lines to the other side, and we want the exact same measure for this green line to be on the other side. Okay, so what we are going to do, we are going to bring our set square and first of all complete the line. This is our first step we are going to do, and then we will measure the line till we have the same distance. Okay, this is our second line, and now I'm drawing them randomly. I'm not drawing them on using a specific distance. Now randomly, and after that I will measure. Okay, and now I will draw my last line and third and last line. Okay, the ruler is a little bit not 100% accurate. Okay, yes. So I draw the lines. Now we are going to measure. So using a ruler, or you can use it is graduated, so you can use it. Okay. So first of all, we are going to measure this distance from B to this point, to this line D, and the same distance on the other side. So it is 4.1. I will put a mark on 4.1 on the other side. Okay, so here it is, and the other one I will measure it. It is about 1.9. So on the other side I will mark 1.9. Okay, and finally from A to the line 6.6. So I will search for 6.6 and I will put a mark beside that. Okay, and now after I have finished my marks, now I can connect these 3 points. So I am connecting them, and here is my image of that triangle. So I want to name that. So the image of E, it is the first letter. The first letter in this triangle, the image of A is E. So this is A. This is the image of A. We will call it E. Okay. So the letter which is the image of B, it is the second letter, which is F. This is B. Its image is F. And the final letter is C. Its image is G. This is C. Moving on the line, this is G. Okay, so in this way we were able to draw a symmetry with respect to a line. So what is that related to our lesson? Because we want to see what are the axes of symmetry in the square, and we have many axes of symmetry in the square. So you can see that the axes of symmetry are the perpendicular bisector of the sides. So this side, the perpendicular bisector, which is perpendicular, and it cuts at the midpoint. So when here this point here is the midpoint of AB, and this line, the red line, is perpendicular to AB. This is the perpendicular bisector. Okay, so this red line is an axis of symmetry. Also, this red line is an axis of symmetry, and the diagonals are axis of symmetry. So this green line and this green line are axis of symmetry also. And you can see that O is the center of symmetry. Why? Because every point have a symmetry with respect to O. So D is the symmetry of B with respect to O, and A is the symmetry of C with respect to O. Okay. What else? So you can see that that also the diagonals are the bisectors of the angles. So angle D, which is all of it, is 90. Yes, so this diagonal, the green one, it cuts this angle in half, which means the 20 over 9, it is 45 by 45. So if I call this angle 1 and angle 2, angle 1 will be 45 and angle 2 will be 45. Similarly for C, B, and A. Finally, how to prove a square. So if we want to prove a square, one of these three conditions, I repeat, one of these three conditions should be true. So either one, either two, or three, not all of them. Okay, so if we were able to prove that the four sides are equal, so it means that AB equals BC equals to CD equals to AD. We want to prove that, meaning that they have told us they are equal. We know that, we are sure about that AB is equals to BC equals to CD, etc. So if the four sides are equal, and we have one right angle, any right angle. So either A or B or C or D, it doesn't matter. So if we have this condition, these two conditions, then this is a square. So we need to have given about the sides and one angle. If we don't have given about the sides, we can prove it by the second method, in which we have given about the diagonals. So if the diagonals are equal, perpendicular, and bisect each other. So you should pay attention. You should prove them equal, perpendicular, and bisect each other. So if you have given about the diagonals, which are AC and BD, if they are equals, meaning AC equals to BD and the angle between them is perpendicular, and they bisect each other, meaning this small segments here, they are equal, as we have explained in the properties. So if these three conditions are found and we were able to prove them, or they were given to us as a given, okay, then we use the second method and prove it by the second method. And if we don't have all of these conditions, the three conditions, if we have that the diagonals are equal and bisect the angles, meaning we know that AC is equals to BD, and we know that, for example, this angle is equal to this angle, and these are 45 degree, and this equals to 45, also this angle and this angle. The diagonals bisect each other, the angles. So if the diagonals bisect the angles and they are equal, then using the third method, ABCD will be a square. We are going to see more. Number 1 and number 2 are going to prove squares usually by these two methods more than the third one. Okay, so you need to memorize them, and that's everything for this video. Keep watching the exercises, and have a great day.